Let's graph another exponential function. This one looks a little bit more complicated, but again, you can use your calculator when you get stuck. I always start with whichever value might be the easiest to enter. And if we're looking at this function, it's exponential because the variable is in the exponent. And if I start with f of 0, if I put in 0 for x, this one becomes very easy. Let's do it and see. So this is problem 2, and we are using the function f of x equals 2 times 2/3 to the x power. And we're going to do f of 0 by hand because it's very doable. So 2 times 2/3 to the 0 power. Now in the order of operations, we raise any base to the exponent first before multiplying by the number here outside the parentheses. Only 2/3 is getting raised to the 0 power. So any number to the 0 power is what? Do you remember? Any number to the 0 power is 1. So this just becomes this same 2 here, but times 1. Not 2/3 to the 1 power, just 1. And so the answer of f to the 0 power, the function of 0 in this function, is simply 2. So I can go back to my t-table and give the output y is 2. Let's try another one by hand. Let's try putting a 1 in for the function. So f of 1, I think we can do this one by hand also. So putting 1 in, function of 1, I rewrite the function, and wherever x was, I'm going to put a 1. So 2/3 to the 1 power. Now any base to the first power is just that same number back again. So I just get 2 times 2/3. And don't be afraid of fractions. 2 times 2/3 is really easy. It's 2 of these. 2/3 and 2/3 is 4/3. 2 times 2/3 is 4/3. And if you like, you can rewrite that as 1 and 1/3. 3 goes into 4 once with 1 left over. And the reason I might want to do this is because this will be easier to graph than 4/3. I can understand this better. So when we put in 1, we got 1 and 1/3. Alright, let's use our calculator on the next one. Okay, so we're going to put in function of 2. So putting a 2 where x is. I'm going to put it in just as I see it. 2 parentheses. Some of you may have a calculator where you have to type in 2 times parentheses. My calculator knows that this means multiply. I'm going to use my fraction key to put in 2 fraction key thirds. If you don't have a fraction key, you can do 2 divided by 3. And now I need to power up. So my power key is the upside down V. I need to power up to x, which we're saying this time is 2. So power up to 2. And it gives me the answer 8/9. 8/9. So it looks like this function is decreasing from 0, 2, 1 1/3, and then not quite 1. Alright, let's try putting in -1 now. I'm going to clear that out and go 2 parentheses or times if you need to in your calculator. Putting in my 2/3. This time I'll do 2 divided by 3 so to show you that that also works. And then power up to a -1. Negative sign and 1. Let's see what we get this time. I get the answer 3. I get the answer 3. Does that seem strange to you? Well, if we did this one by hand, which I'll do quickly to show you why the answer is 3, f of -1, when I put in -1 here, it means inverse, or flip this upside down. So I'll get 2 times 3/2. That's what the -1 means in this case. I'm going to send 2 to the downstairs and 3 to the upstairs. I need to flip this upside down. Well, 2 times 3/2 is 6/2. 2 times 3 on top, 2 times 1 on the bottom, and that is 3. So that one turned out kind of nice. Alright, lastly, let's put in -2. Alright, so 2 parentheses. I'm going to go back and use my fraction key. 2 fraction key thirds. And I have got to power up, and this time to -2. And what do we get? 4.5. I get 4.5. If you used divide instead of fraction key, you probably got 4.5. Same thing. Alright, now we're going to graph this function, and on the x-axis that's going to be pretty easy because I'm just going 0, -1, -2, 0, 1, 2. I'm going to skip spaces, 2 spaces for every unit just to make it a little easier to work with. Again, skip consistently. If you skip 2 spaces, skip 2 right away. Now I'm going 8/9, 1 1/3, 2, 3, 4 1/2. I think, do I have room to go 1, 2, 3? Yes, I do. I'm going to put 1 here, 2, 3, 4. So that'll get me to 4 1/2 with a little extra space for those fractions in between. I don't need to number into the negatives. If I did, that would be -1, -2, -3, etc. Okay, let's take a look at -2, 4 1/2. Left 2, up 1, 2, 3, 4 1/2, because 5 is here, and I want to go halfway in between. -1, 3. Left 1, up 1, 2, 3. Okay, this is an exponential function. It should make a curve. By the time I graph the next point, it should start look like it's curving. 0, 2. 0, don't go left or right. Up 2. Doesn't look like a curve yet. Let's try the next one. 1, 1 1/3. To the right 1, up 1, and not quite a half. Now it looks like it's going to start curving. Over 2, up 8/9. So over 2, not quite 1. So just below 1 there. And indeed it does start to curve, so that if I connect these dots with a nice flow, and this will probably keep going, and it'll probably never reach the x-axis. So it's just a very gentle curve. And that's that.